let's go on.
So since we're almost at the end, do I need to send you some more problems? Because I didn't think we were at the end. I forgot.
Is 25 the last?
Yeah, the 25 per section.
Okay. Yeah, go ahead and send me some more, because we'll get through 24 and 25 today for sure.
Okay. Hold on just a minute while I grab my iPad.
Go ahead and do that.
You can go ahead and explain while I take pictures of the next page.
So the student says that for any integer n, the integer 4n plus 3 is prime. Which of the following values of n disproves that? So we want to, this is perfect for back solving, right?
Right.
In other words, all we have to do is plug in any of these 5 numbers, and if we get a number that's not prime, it disproves the student's conjecture.
Okay.
Excuse me, I'm getting over the flu and I'm still coughing a little bit, but I feel about 1,000% better than I did 2 days ago. Not a good time to get the flu, the finals week.
No.
But, all right, so let's test 1. Indicate all such values, which means we have to test all of them. And it's relatively easy. So let's test 1. What is 4 times 1 plus 3?
4 times 1 plus 3 is 7.
That is a prime number, so that does not disprove the conjecture. It doesn't prove it, but it definitely doesn't disprove it. Now try 3.
3 times 12, 3 times 4 is 12 plus 3 is 15, which is not a prime.
That proves it. How about 4?
4 times 4 is 16, plus 3 is 19, which is a prime.
So that doesn't prove it. How about 6?
Wait, it says that 4n plus 3 is a prime number.
Yeah, notice what they say here. Which values of
to disprove it. Okay.
Disprove, which means that any of these values that produce a non-prime number disprove the student's conjecture. So far, 3 disproves it because we came up with a non-prime number. And
so D is a prime number.
D is, no, it isn't.
6 times 4 is, because of 27, right, okay. It's not a prime number.
Okay.
And 7 times 4 is 28, plus 3 is 31.
Hold on. Well, now you got me confused. 6 does prove it. Does disprove it, excuse me. In other words, 6 comes out 27. That's not a prime number. So using either 3 or 6 disproves his conjecture. How about 7?
Right.
How about 8?
7, it's a prime number. It's 31.
That does not disprove it. So the only answers are B and D.
Wow, that's tricky. The reading test.
No, it is tricky, but I've noticed that whenever they have a chance, they try to get tricky and they reverse it almost always. In other words, they could have made this real easy and say, well, I'm not sure, but they've definitely reversed everything. on most of these questions. So it's very common to have to disprove something. And as all you have to do to disprove something is to find one case. So all I have to do is find any integer where 4n plus 3 is not prime. And 3 does that, and so does 6 do that. With either of these numbers, I could disprove the student's conjecture. Always, first step, I do that when I've read only that much of it. I know I got to draw a circle.
Right.
And they're equally spaced on the circle. Okay, equally spaced is not easy to do. There's 4 points equally spaced, so that would be 8 points equally spaced. And that satisfies that right there. 8 points are equally spaced on a circle. If 4 of the 8 points are to be chosen at random, what's the probability that a quadrilateral having the 4 points chosen as vertexes will be a square? Wow. Well, the only square I can see that we're going to get is if we do something like that.
There should be 2 options.
Well, at least 2. What other squares can we get? We can get a square if we do that. I don't see any other squares that are different.
No, I don't either.
That's the only way we can get a square. Well, hold on a second. If 4 of the 8 points are to be chosen at random.
Oh, so they don't have to make a square.
What is the probability that a quadrilateral having the 4 points chosen will be a square? Well, those are the only 2 squares we can get. So let's see.
But there are many more possibilities, but yeah.
Well, no, but none of them produce squares.
Right.
So the only 2 that produce squares are 1, 2. Start again. Hold on a second. This is one of those tricky ones, as all 25s are going to be. So we've got...
I thought you said some of them are easy.
Well, we actually did come across some that were easy. So, but in general, when I see a 25, I know it's going to be hard. And we also have 2, 4, 6, and 8. So our 4 points have to be one of those 2 points. In other words, those are the only 4 vertices that come up with squares. Well, this sounds like 4 choose 2. In other words, how many different ways? No, it doesn't. Well, how many ways, I guess the answer is, how many ways can you connect, how many ways can you make a quadrilateral from 8 points? Notice that I can make a quadrilateral this way also.
Yeah, you can.
So I can make a lot of quadrilaterals. So
You can.
I can figure out how many quadrilaterals I can make. I know only 2 of them are squares, and that would be the probability.
Right.
So how many quadrilaterals can I make? Wow.
So would that be 8 factorial over 8 factorial over 2
Well,
factorial?
let's if we're going to lay it out like that, let's make sure we get, is it a permutation, is it a combination, and what is NCR? And then we can solve it.
Okay.
Actually,
Order does not matter, does it?
There's more than 2. Notice that the blue.
Oh, right, because you can pick a different point.
I can hold on a second. No?
You can do 1, 3, 5, and 7, or you could do,
Well,
does it matter?
5 and 7 is the same. I've already got that. That's not a different square. And 2, 4, 6, and 8 is a different square. But how do I get a different square other than those 2? I don't think there is.
No, there isn't.
Okay. So it's all we have to do is figure out how many quadrilaterals we can make. So
Right.
to me, that seems 8 choose 4. Because to make a quadrilateral, I got to choose 4 points. And I'm choosing from 8.
So 8 factorial over 4 factorial?
No, that's not the formula. This is the formula. C n choose R is n factorial. The denominator is n minus r factorial times, is it n or r?
N. I mean R.
Remember, there's always 2 n's and 2 r's. So it has to be r, not n. Okay, what does 8 choose 4?
So that would be 8 factorial over 8 minus 4 factorial times 4 factorial.
Okay, which is 8 times 7 times 6 times 5 all over 4 times 3 times 2. Make sure you understand how I get that.
Because you canceled out one of the 4 factorials.
Yes.
And the 1 factorial is just...
In other words, that took care of the 4 times 3 times 2 times 1. And I'm still left with a 4 factorial in the denominator, so I still have 4 times 3 times 2. Now,
and you can factor out the 3 times 2 and 6.
Well, let's just cancel that. And I can factor out that and that. So it appears to be 70 over 1. So there are 70 different ways I can make a quadrilateral. Only 2 of those result in squares. Can you look up the answer?
Sure. Let's see, here's the book.
These tough ones. I think I've got it right, but I might not. I could definitely be wrong. But I believe it's 1 over 35. And notice.
But why do we have 70 on top and 2 on the bottom, and then the 1 on the bottom, and then it's 1/35?
Because there's 2 ways. This is how many ways you can make a quadrilateral. And of those 70 ways, 2 of them are squares.
Oh, I see. Okay. But why is it 1/35?
Well, because it's 2/70. In other words, there's 70 ways to make a quadrilateral. Only 2 of them result.
Oh, I see. Okay. Got it.
So that's what I should get. Now, just let me say something before you tell me whether that's correct or not. I don't honestly know whether I should be doing a permutation here or a combination. But I do know that if I did a permutation, I'd end up with 8 factorial over 4 factorial, which would be a whole lot bigger than 70. And no number bigger than 70 works with any of the answers. In other words, 70, I could deal with 140 maximum. I could not deal with 280. So it's got to be a combination problem. It can't be a permutation problem. You know, that sounds like a little bit of strange logic, but in this kind of a problem, it's difficult to tell whether you want to do combinations or permutations. So far, we have not come across a permutation problem. Every problem we've seen has been a combination problem.
Huh.
Which is good. That means when you come across a problem where you know you have to use one of these, just go ahead and choose combination and you're most likely going to be right. So what's the answer on this?
You are correct. It's 1/35.
All right. Did you send me the other thing yet?
Yeah, getting there. It's going to be a little confusing, but because I don't have time to edit the photos, and it's a different book. It's the Princeton Review because we've done all the ones that are in.
That's fine. Different is good, even though the makers of the test, that's the best one. But I've done Princeton Review for a lot of people, and they're fine. My number one choice would always be the people who make the test. After that, my last choice would probably be Kaplan.
Last choice.
Yeah, if you're going to go out and buy a book from Barnes & Nobles, don't get the Kaplan book. Get Princeton Review, or what are some of the others? Barron's. Any of those are better than Kaplan. I got Kaplan books for the first 3 or 4 years I tutored, and they're not as good as everybody else. Well, I don't know what else to say. So now, you sent me a PDF file?
I'm trying to. It's
going to take a long time to get to me because it's a lot of data in that attached file.
Yeah.
Is there anyone that you can read verbally while we're waiting for it?
Okay.
But go ahead and finish trying to send it. In other words, you got to get it to a point where it says file sent. And then you can go do other things.
It's going to be by photos instead of a PDF. Is that going to be a problem?
In that case, take one photo and send it to me. Because the more photos you put on an email, it's exponentially a longer amount of time to get to me.
Right.
So if you have 6 photos, do not put all 6 of them on one email. Send me one, and then you can put the other 5 on an email as long as we don't need to do it for 10 minutes. Because it'll take 10 minutes for the second 5 to get to me.
I'm sending one to you.
All right. Tell me when it says file sent. There's no point in me looking before then. I mean, a lot of people tell me to, okay, I sent it, and I look and it's not there, and then 2 minutes later they say, well, it still says file sending. Well, it's got to say file sent on your end before it can possibly be on my end.
I'm looking.
Okay. You use an iPhone or do you use a Samsung, Carolyn?
iPhone. This is on my iPad, though.
And you want to attach it as a large image. And you want to attach it, you don't really want to embed it. Although I can sometimes handle embedded files, but if you attach it, I can download it and then I can rotate it if I need it. I can zoom in, zoom out. I can do lots of things as long as you attach it as a file. Sometimes I'm limited.
They say they're in my sent file, so.
Okay, I got them.
2 different ones.
Yeah.
The first one is obviously the earliest one.
Okay, let's do this. This is weird because it's a different book. Okay, so we have 1 of 20. So the first question is over here on the left. Okay. All right, let me take a picture of this. These should be relatively easy. First of all, I think the quantitative comparisons are the easiest part of these tests. You agree?
I agree. Yeah.
Which is so different than the GMAT. In the GMAT, the what do they call it? Data sufficiency part is by far the toughest part of the test, and maybe the toughest questions I've faced in my 8 years of tutoring. And I found it rather interesting that law schools have changed, a lot of them, in that they do not require the LSAT anymore. They will put up with the GRE.
Oh, really? Huh.
Which is pretty interesting. Because the GRE is by far the easiest one. By far. On a 10-point scale, I would say the GRE is a 5 and the GMAT is probably a 7 or an 8. And the LSAT used to be like a 9. So they're allowing people that would have had to take the LSAT to get by with the GRE. I don't know if that's going to change the lawyers in this country over the next 30 years, but I find it very interesting that the people that have to take the toughest test are the people going into business school. Not science, not law. And I'll bet you anybody that can take the GRE as opposed to the LSAT will do it. The LSAT is a exercise in logic. And so is the GMAT, the GMAT. That tends to be more logic than it is anything else.
Okay.
And these GRE are, I don't know, maybe it's just a personal thing for me. I find the GREs to be relatively easy, the GMATs to be super tough, and the LSAT I can't even help anybody on. All right, let's look at number 1. What's the first thing we're going to do?
Draw a circle.
Good. Got to take a snapshot. My Windows Ink workspace is acting up lately. It's not so willing to let me take a snapshot as it used to be. Huh. I haven't quite figured out what's going on. Let me back up and try this differently. And see, now I can't expand it is the problem. Well, maybe I can get by without expanding it. No, my work thing is not working. Let me try this again. I saw it come on. It may just be delayed. I may just not have waited long enough for it. Let me try it again. I don't know if you can see what I do when I'm on my taskbar clicking. Can you see where my cursor is right now?
At the moment, no.
Okay. I'm trying to open up Windows Ink Workspace, which is what takes a snapshot of my screen and allows me to draw on it.
Uh-huh.
It's acting extremely slow lately. Seems to be getting slower all the time. And now I can't even get it to open up. So, let's see if we can do this differently. Edit and create. How about we just draw? See what happens if we draw. Okay. Who needs Windows Ink Workspace? Okay. So we're going to draw a circle with radius of 6. Circle R with radius of 6. And is inscribed in a square. You can always inscribe a circle inside of a square. Now, any questions as to what's the difference between inscribed and circumscribed is?
Would circumscribed be the square inside the circle?
Yes, exactly. Now, naturally, it's not anything as easy as the area of the circle or the area of the square, but we can figure out the area of the circle. That's pretty easy. What's the area of the circle?
If I recall correctly, that's 2 pi r.
If there is one thing you need to know, it's the area of a circle and the circumference of a circle.
Oh, the circumference is 2 pi r, so it's pi r squared for the area.
Okay. I mean that. There are no two more important formulas to know. Okay, so that's the area of the circle. Hold on. We know the radius, so it's 36 pi. Now, the area of the largest triangle that can be drawn inside the square. Well, first of all, if I draw a triangle inside of a square, what is its area going to be relative to the square? It doesn't matter if I draw it like that. It doesn't matter whether I draw it like that. The relationship is the same.
Is it half?
Yes.
Of the square?
That's why a triangle area is 1/2 base times height. It does not matter what the base or the height is. It's half of the rectangle. In other words, if I draw a rectangle and I put any triangle in there I want, I can put that triangle in there. That's half of the area of the rectangle. I can also put that triangle in there. That's half. I can also put that triangle in there. That's half. So all triangles that get inscribed in a square, the maximum they can be is half of the square. Now, what's the area? So we know it's going to be half. Let's figure out the area of the square.
So would you need to get the diagonal?
No.
Of the square?
To figure out the area of a square, you need its side length. What is this?
Well, That would be 12 because
And we
the
know
radius
the
is
area of
half.
the square. What's the area of the square?
144.
Now what's the area of half the square?
72.
That's the area of the biggest triangle that can be inscribed. Now compare those two numbers. Which one is bigger?
Quantity B.
Yes. Okay, now, interesting. Boy, good thing tutoring's almost done for a few weeks. My computer seems to be not behaving nicely. I guess question 2 is on another page. So let's do 3 and 4, and then I'll open up the second page if we have time, and I'll do 2. Okay?
Okay.
There it is. Now my Windows Ink workspace is working, so I can use my normal writing. I missed that color. All right, so we got the remainder when 135 is divided by 7. Well, this can't be too tough. What is that number?
Hold on, getting my calculator here. $135 divided by 7. Remainder is 19.2857143.
That's not the remainder. You can't have it as a decimal. If I divide 4 into 9, goes twice with a remainder of 1. So the remainder is 1/4. And actually the remainder is 1, according to this problem. So you kind of need to do this manually. You can't do it on your calculator. Your calculator is going to give you a decimal, which doesn't do you any good.
All right.
So do it manually. Divide 7 into 135. Goes once. That goes 9 times. And I get a remainder of 2.
Okay.
That number is 2.
Is that 19 on the side?
Yeah. So now if I divide 19 into 135, again, manually, not in your calculator. Now, let's see. This looks like it might go 7 times. 7. Remainder of 2.
They're equal.
Yes, they are. They don't get any easier than that. We had to basically do no logical thinking at all. The one thing we had to do was realize we could not use a calculator.
Right.
Because you will not get the same number. In other words, the first one is going to be 2 divided by, what was that, 7? The second one's going to be 2 divided by 19. So they will be different numbers on a calculator. But the remainders are both 2.
Yep.
All right. A and B are integers. And it looks like this says A cubed equals B cubed.
Okay.
So what do we want to try here? In other words, we're
to disprove it?
What's the cube root of A cubed?
A.
Exactly A. It is not plus or minus A.
Oh, right.
Because it's an odd power. If it was A squared, the square root of A squared would be plus or minus A.
Mm-hmm.
You might not be able to come to any conclusions. But if I take the cube root of both sides, I get a equals b, because the cube root of b cubed is b. It's not plus or minus b either. So this is pretty easy also. The two quantities are equal.
Right.
Now, if you didn't realize that, we could try some numbers, and the key here is to always try both positive and negative numbers. So let's try 2. Well, 2 cubed equals 8. So is there any other number cubed that equals 8? No. 2 is the only one. Minus 2 cubed equals minus 8. The only other number that cubed equals minus 8 is minus 2. Whenever you're taking odd roots, you only have one answer. You do not have plus and minus. You get plus and minus when you're taking even roots.
Mm-hmm. Good to know.
Yeah, for sure. Okay, let's see. We need to go back and find 2. That's probably on this page here. Yeah, there's 2 right there. Let's see there, it's working now. All right, I'm going to write this out just so it's more visible. A over XS, is that right? Equals 632, and A over YS equals 158. So which is bigger, A or X or Y?
Well, I'm guessing because if you're dividing by something, if you get a smaller number, then the number you're dividing by has got to be bigger, right?
Problem is that that's not the same as that. So we have to do some more math here. Solve the left side for X. Once you solve the left side for X and the right side for Y, it'll be a piece of cake. So how do you solve that for X?
I'm not really sure.
Right, you multiply by the denominator. Whenever you're trying to get rid of a denominator, and you always are, all algebraic equations, you're trying to get rid of the denominator. So we multiply both sides by XS, which gives us this.
Okay, because I wasn't sure if you had to separate X and S, and that.
Well, not yet. No, I'm trying to isolate X. I can easily isolate X now. First of all, I've got it in the numerator. So X is equal to A divided by 632S.
Okay.
Now let's solve for Y.
So that would be A equals.
No, we're solving.
Y equals A over 158S.
Yes. And now it's relatively easy to compare these two. Which one is bigger?
158S.
Y.
Y, yeah.
And you're right, because the denominator, 158, is smaller than 632, everything else is the same. In other words, I have an A in the numerator and I have an S in the denominator. So there's no numbers you can put for A and S that make Y less. let's just check a negative number. What if I had -1 for A, +1 for S, and I'm comparing that, that's X. And if I put -1 for A over here, over 158, because I'm going to use the same S. Now, that is a smaller negative number, which makes it a bigger number.
What?
This number right here is a bigger number than that number right there. For the same reason that 1 minus 1/3 is greater than minus 1/2. If you look at a number line, there's 0, there's minus 1/3, there's minus 1/2, which one?
Oh, I see what you're saying, yes.
So only
Then it's D,
if they
right?
said that X and Y have to be positive, then we would be able to tell which one was bigger. But the fact that they didn't put any restrictions on A or S, well, they put one restriction. It can't be equal to 0.
At least X and Y can't be.
Right. X times Y can't be 0. So neither X nor Y can be 0.
And neither can S.
Correct. Correct. So none of them can be 0, but I didn't pick 0. I picked -1 for A and +1 for S. Whereas if I pick +1 for A and +1 for S, I get quantity B is bigger.
So it's D.
Depending on whether you pick positive or negative numbers, you get different. Sometimes X is bigger, sometimes Y is bigger. So I'm going to say D. Can you look this up real quick? Because this
I'm looking it up.
Puzzles me a little bit. I think I did it right.
2 is D.
Okay, good. So let's look at 5. 2 is definitely a little tricky, because if you work with positive numbers only, even after you go through all that algebra, you'll get it wrong. You'll assume that B is greater than A.
Right.
So whenever you have a question like that, always make sure you check it with positive and negative numbers. And for that matter, fractions. In other words, it doesn't tell you anything about X and Y. They could be fractions, positive or negative. They just can't be 0.
Right.
Is that my TV that came on? I think it is. Hold on one second. Let me go turn it off.
Okay.
Sorry about that. I can't tell you how many times that happens. I put my TV on pause, and I have Comcast, and so it automatically comes on after an hour. And I always forget. I need to turn the TV off if I don't want it to come back. So, all right, let's look at 5. Okay, I've already taken a snapshot of it. So, which is bigger, AC or 6? Well,
AC or oh, the number 6. No, that's a 0.
Let me blow it up a little bit so I can see it a little bit more. You're right. Okay. Probably makes it easier. No, seriously. Because now is all we have to do is tell whether that's negative or positive. Right? In other words, before we would have had to compare it to 6, which is much tougher than comparing it to negative or positive. So we got to pick some numbers for A and C. Let's pick all combinations we can think of that are either positive or negative. So give me an
A has to be negative if it's less than 0, right?
No, B could be negative.
Oh. True.
So let's look at that logic a little bit. Either A or B has to be negative. They both can't be positive.
Well, if B were negative, then C would also have to be negative.
Hold on. Let's write A or B has to be less than 0. And this one says B or C has to be greater than 0. So let's see. A could be negative, and B would be positive, and that would be true. And then C would have to be positive, right? So let's list our combinations. We don't have that many of them. A can be negative, which means B would be positive automatically. So there's one possibility that satisfies that. The other possibility is A is positive and B is negative. And that's the only two possibilities that satisfy that condition. Now, the second condition, B can be positive, which means C has to be positive, or B can be negative, which means C has to be negative. So those are the only two possibilities that satisfy that.
Right.
So we've got C can be positive or negative. B can be positive or negative. A can be positive or negative.
Right.
So let's see, what's the best thing we should do? Let's try some numbers for each of these 4 combinations. Give me a number for A that satisfies top left.
-2.
And a number for B.
3.
So that would be -6. Now we got to use the same numbers.
We also need a number for C.
Yeah, well, if B is 3, then C would have to be positive. And if B is negative, then C would have to be negative. Let me think about this one for a minute.
What's the question?
Which one is bigger? Is AC, actually the question is AC positive? 0? Can't be 0. Notice. So we can eliminate this. No way is it C. The only way it could be 0 is if A or C were 0, and if A or C were 0, neither of those would be true.
Correct.
Okay. So if we're down to guessing, we've eliminated one of the answers. Now the question is, can I pick an A and a C that result in a negative number and a positive number, and then I'll know the answer is D.
Okay.
So let's try to do that. If I pick my original -1 for A, and C, well, let's pick a negative number. Well, now AC is positive. Now, and that would work because I can make B anything. In other words, I could make B a positive number, and that would be true. But that would not.
Aha. So A and C always have to be opposites.
Which means quantity A is less. Do they have to be opposite? What if AB was +1, which would mean B has to be negative.
Oh, right. Uh-huh.
And BC, C would have to be negative also.
Mm-hmm.
So in this case here, I satisfy both of those conditions.
Right.
And A is bigger. Excuse me, AC is less than 0.
What, less than or greater than?
Well,
less than,
A is plus, C is minus, so A times C is minus.
Okay, so then you need to change your sign up there.
Yeah, that was old thinking. I meant to. Okay, so if A is positive, B has to be negative, and if B is negative, C has to be negative. And now, if I make A negative, then B has to be positive, and if B is positive, C has to be positive.
Right.
So I think those are the only two possibilities.
Right.
And
so it's
A times C is negative, and A times C is negative, so 0 is right.
Quantity B. Right. Okay, that makes sense.
Do you have the answers in front of you? I always like to check. I think we did this right.
Let's see here. Section 5, number. What number was that?
Number 5.
Number 5. B. Yep.
Okay, good. The real secret to this problem was narrowing it down to these two possibilities. And those are the only possibilities that satisfy both of those inequalities. In other words, A is, I should have just said positive, therefore B is negative, and C has to be negative. And if A is negative, B has to be positive, and if B is positive, C has to be positive. So these two are the only possibilities. And in both of these possibilities, A times C is negative. Excuse me, it's positive. In both of these cases, A times C, that's positive, which makes what happened here?
Well, when A is positive, B has to be negative, and when B is negative, C has to be negative.
Okay, so that's this case. And if A is negative, B has to be positive. And if B is positive, then C has to be positive.
Right, so you can't have both A and C positive and both A and C negative.
Right.
Because they won't match.
B is positive in either of those two cases, which makes AC the greater one. It's quantity A. that's bigger, because AC has to be positive. There's only two ACs, and that's if this A is positive, this C is positive, that's one of them. And the other AC is if A is negative, and then C has to be negative. So in either case, AC is positive.
But they don't fit the scenario up on the top.
They do. In other words, I have two scenarios here. Let me rewrite all of this.
I mean, based on the equations at the top, you can't have a negative A and a negative C.
Hold on. If A is positive, then B has to be negative. And if B is negative, then C has to be negative.
Right.
That's one scenario. The only other scenario would be A is negative, which means B has to be positive. And if B is positive, C has to be positive. So A times C is positive in that scenario. A times C is positive in that scenario.
Correct.
So AC is positive, which makes quantity A bigger.
Yes, but if A is positive, it doesn't mean for if A is positive, B cannot be positive.
That's correct. That's why I said A is positive, B is negative.
Right. But you can't have a positive.
In other words, what I have circled there are the only two possible scenarios.
Right. So why, I don't understand why you're crossing them.
Because that's multiplication. A times C is a positive times a positive. Or this A times this C is a negative times a negative. So AC is positive regardless of which AC you use. As long as these are the only two possibilities, and I can't think of another one, and in both of these possibilities, A times C is positive. Can you check
so you're saying,
check your
are you
before we end the session? Kind of like to see if this is what the answer is here, the proper answer for number 5.
The answer said that it was B.
Yeah, that's what you said the first time, and I don't get it.
Not B. I'm sorry. Ugh. What did it say? Hold on.
That's what I originally thought, but in further thought, it looks like AC has to be the bigger quantity, only because it's always positive. And it can't be 0 either. So it has to be a positive number, and any positive number is greater than 0. So
number 5.
The problem with that answer book is there's lots of number 5s in each test, right?
Okay, section 5, number 5 says B.
Says B.
Quantity B is greater.
Does it give an explanation?
It says plug in numbers. Okay, so if A equals -2 and B equals 3, and C equals 4, then AC equals -8. Quantity B is greater, eliminate A and C. If A equals 2, B equals -3, and C equals -4, then AC is still negative. Quickly consider different numbers, but realize that quantity A will always be negative.
I don't get that. How come quantity A can't be positive? If I plug in plus 2 for A, that means B is negative. So that's less than 0. There's A, there's B. And now, if B is negative, C has to be negative, because negative times negative is greater than 0. That's C, that's B.
Because they are not considering the multiplication that you're doing of A positive, C positive, A negative, A negative.
I'll tell you what, let's table this one. Let me think about it for a while. I still think I'm right, but I can't explain why your book says B. I don't know that we have enough time to reconcile it at this point. So
okay.
Let's start on this one on Sunday, and I'll give it some more thought and see.
I'll see you then.
Something that I'm missing. All
okay.
right, Carolyn.
Great. Thank you.
Talk to you on Sunday. Bye-bye.
Okay. Bye.